Hello Internet, this video is going to be dedicated to a most powerful bit operator called XOR. I love this XOR operator, it is such an awesome operator, and the reason why I love it because it has a very simplistic property, very basic and a simplistic property, which is that if you have a same values on both of the side, it will return a false value. If you have the different values, then it will return truthy value. That's it, nothing beyond that, as simple as that. But using just this simple characteristic of this XOR operator, you can actually achieve some of the complex stuff. You can solve some of the complex stuff. You can apply this rule, this law, to solve some of the complex problems in a programming language. And not just you solve them in a very efficient way, and it is very performant. It takes very less compression to do that. But before that, I want to show you like what exactly XOR is, because some of you may not be aware of it. So what does a XOR does internally? It basically just performs then binary operations. It's a binary operator, as I said, like it performs a binary operation on the numbers. That means the numbers has to be converted to the binary. So I just have a bunch of console logs over here in my nvim, and what I'm doing is just like simply trying to see what exactly it does. And let me do this and run the script and see what are the output. So what I got for the 3 XOR 5 is 6, then 7 XOR 7 is 0, and then a couple of numbers over here that returns 3. So I guess out of this, the second one is the most easy, and I guess you could easily understand why it returns 0, because as XOR says that if you have the same numbers, then it will return falsy all the time. Okay, but in case of 3 and 5 it returns 6. Let's try to understand why. And when we do a XOR on this, what we get is this thing. So 1 XOR 1, as we know that if it's the same, then it's a 0. 0 XOR 1 is actually 1, and here as well 0 XOR 1 is 1, because the numbers are the different. So what I get as the result is 110, which is actually a binary representation of a decimal number 6. That's why we got output as a 6. Now I think it is crystal clear to you guys like what is exactly happening when we do a XOR. And if you're wondering on the third example why it return 3, that is because you can actually swap the order of the XOR operator on the numbers. That means you can like do 1 XOR 1, then you can do a 2 XOR 2, and then you can do a XOR of 3. That means you have 1 and 1 similar, then 2 and 2 similar, and when it is similar, then it is 0, and 0 and 0 will basically return a 0, and what you're left with it is just a 3. So 0 XOR 3 would be just like a binary of a 3 and a decimal of a 3 as well, so you get a 3. So it's just a property of the XOR that you can like basically switch the order. That is called as a commutativeness. Now things are getting spiced up. Now we are gonna take some real world example that you can actually use in some of the use cases. What we are trying to achieve over here is we want to find out a missing number in a pattern, as simple as that. Okay, so what I got here is a simple array which has some numbers in it, and then I said like how many numbers that I'm supposed to have in an array. So I said like I supposed to have the 5 numbers, but I provided only 3, and I want to find out what is the missing number. And here the sequence is very simple. Like each time we are incrementing a value by 1, the sequence is very simple, but the sequence can be like anything. You can like have maybe a increment by 2, or the multiply by 2, or the power to the 2, or exponential to the 2, or the log of 2, whatever you can imagine. The sequence can be anything, but the task over here is we want to find out what is the missing number. So what we are doing over here is like we are just like iterating over through the indexes of each of those elements in the array, and we are performing a XOR of that and maintaining that in one of the temporary variable called result, which actually is initialized with a 0. And then we actually again perform a XOR of that result, but this time we perform a XOR with actual value. So you see second for loop, we have v of 8. That means we have the values, we don't have the indexes over here. We are dealing with actual values in the array. So we are dealing with the 1 2 4 5, these values, and not just like the indexes would be basically 0 1 2, but values will be 1 2 4 5. I intentionally put a console log here so that I want to show you like what exactly happens over here. And let's run this and see what is exactly going on. So what happened first is, let me just get rid of this. What happened first is the value of result was 0, then it became 1 because we performed the 0 XOR 1, and of course we got a result 1. Then 1 XOR 2, we got 3, and similarly we kept on moving on ahead. and we got 0, and we got 0 because this time it was 3 XOR 3, and of course when the values are same then it returns the 0. And then we got 4 and 1, and now we stopped there and the result was 1 at this point. Now we started with the same result value, but this time we were using the actual values of the array and not the indexes. So it was like 1 XOR 1, which is 0 this time, then the 0 XOR 2, which is 2 again, and similarly then 2 XOR 4, which is 6 again, and it kept on doing that, and magically apparently at the end of it we get a number which is 3. So it is such a simplistic thing. I love the beauty behind it. Like, it's such a simplistic nature of the XOR that if the values are different, it would basically say I'm truthy. If values are same, it would say that I'm falsy. You can use this simplistic property in a application like this, where you just basically iterate over some sequence and perform the XOR in the sequence, and then ultimately what you get as a result is you find out that missing number. I find it very creative and attractive because this is a simplistic property and you're using that to get something meaningful out of it, and it is actually very efficient. The number of computation that you're doing with a XOR are very less than what you do with addition plus or the multiplication, because XOR operates on the binary levels and the binary operations are pretty fast, because internally you're just flipping out the bits 0 to 1, and what you're doing is just like flipping only one bit at a time, so it's very fast. And the last example that I'm going to show you, finding a non-repeated element in a sequence, in an array, whatever you call it. So what we got is an array again this time, which has a value 1 2 1 3 2. So we have 1 repeating, we have 2 repeating, and 3 is the only number that is not repeating, and we can find out 3 very quickly using XOR operator. And what we are doing here is simply using a reduce method on the array. That reduce method will basically take the accumulator and the v. So if you don't know what reduce does, is basically perform the operation on the elements of an array, but in a sequence. So for example, calculating the sum of the elements or calculating the factorial, those things can be achieved with the reduce, and magically somehow it returns the value which is not duplicate here. So this though may appear as a magic, but the logic and the math underneath is very simple. If you remember what I showed in my first example, I said that the XOR operator has this property of the commutativity, which means you can actually swap the order of the numbers and you can perform XOR on them. In this case, we know that 1 XOR 1 and 2 XOR 2 will be same as you perform XOR on this in any order, so order doesn't really matter here. So what we got is the 1 and 1 cancel each other, 2 and 2 cancel each other, and we simply know like there's only one number which is not duplicate over here. So this is very quick actually. If you're using a XOR operator, this happens very fast in the computer, and I simply love the way that we can utilize the XOR operator in such a small scenarios. It makes a lot of sense to use the XOR operator.